Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've seen that in the log level model with an interaction, the percentage effect of x depends on z. So now let's make that concrete with numbers. For step one, we're going to work with a particular model. So let's assume that we have an estimated model where ln of y is equal to 6 plus 0.08x plus 0.02z, and then 0.01 x times z, okay? And again, here, x is years of education, and z is years of experience, and y is our monthly income, but now it's in logs. All right. Before computing anything, you can also ask yourself, do you expect the percentage return to education to be higher for more experienced workers or not? Usually, it's always good to have an idea of what you should be expecting because that also helps you when you do the interpretations. Now, let's write, as usual, the marginal effects. So we're going to have delta ln of y with respect to x being equal to 0.08 plus 0.01 z. So the percentage return to education, again, is not a single number. It depends on experience here. And a 1 unit, so a 1 unit increase in x, meaning years of educations, is associated with y changing approximately or increasing approximately 0.08 plus 0.01z%. And as we said, because this is not complete, not enough, we also need to evaluate at different values. So we can do, as usual, the more straightforward, if z is equal to 0, then we clearly have, so keep in mind, z equal to 0, this is the no experience case, we're simply going to have 0.08 times 0.01 times 0, which will times the 100%, so let's not forget the 100%, which will give us simply 8%. Now, if z, let's say, is equal to 5, then we're going to have 0.08 times 0.01 times 5, all of this times 100%, which, if you do the computations, you'll find out this will give us approximately 13%. And then one last computation for z being equal to 10. We're going to have 0.08 plus 0.01 here times 10. All of this multiplied by 100%. If you do the computations, you'll find that this will give you 18%. Okay, so as you can see, each additional year of education increases income by 8% for someone with no experience. Okay? But the moment that you have someone whose experience is 10, then that change is actually 18%. So this is a very large difference that it's entirely being driven by the interaction term. Okay? So the percentage return grows by 1 percentage point for every additional year of experience as well. And then if we've got simply the beta 3 times 100%, you only have literally, so in here, why am I saying this? So in this particular case, if we are looking at like one additional year of experience only without looking at that 0.08, then I literally have that this is just a 1%, okay? Now, beta 3 being 0.01, telling us that each additional year of experience increases the percentage return to education by 1%, means that if we connect that to the core interpretation, now the beta 3 is not the percentage return to education, it's just how much the percentage return changes as my Z is increasing by 1 unit. And as we have very clearly seen in here, when we move Z from 0 to 10, we can very clearly see that gap widening even more. Okay? If you wanted to flip the interpretation, because as we know, it's always symmetrical, you can always look at the derivative of ln y with respect to z, in which case you're going to get the 0.02 plus 0.01x, okay? And as in the previous case, you can try and calculate yourself x equal to 0, x may be equal to 8, and then x equal to 16. Try and do these computations and see how the percentage return to experience also depends on education, and that basically education and experience are reinforcing each other in percentage terms. Okay? So if you do the computations on your own for this case, you'll find that for the first one should be 2%, 10%, and 18%. All right? Now, the big takeaway is that in the log level model with an interaction, just like we have seen in here, the percentage effect of x varies with z. Beta 3 is still consistently telling us the rate of that variation, or like the rate at which this gap is increasing or decreasing if we had a negative value. And as usual, you must evaluate these expressions at different values so that you can interpret it correctly. Okay? The only thing we should never forget is that, as we've seen in this worked example, in this log level interaction model, the percentage return to x is this beta 1 plus beta 3 z times 100. So it's always in percentage terms. I hope this was helpful, and stay tuned, and I'll see you in the next video.